Hello everyone, my name is Dr. Paripasi Sambun. I am an instructor from Information Technology Program, Faculty of Science and Technology, Nakhon Pathom Ratchapat University. Today, we are going to learn the fundamentals of visual computer programming. Lesson 8, Repeating Blocks. In this lesson, we will learn how to program repetition with special repeat blocks and explore an example of repetition app, sending an SMS text to every phone number in a list, and how to add up a list of numbers. Moreover, we will also learn how to significantly simplify an app by using repeat blocks in an App Inventor. Let's get started. In previous lesson, we learned that we define an app's behavior with a set of event handlers, events and the functions that should be executed in response. We also learned that the response to an event is often not a linear sequence of functions and can contain blocks that are performed only under certain conditions. In this lesson, repeat blocks are the other way in which an app behaves in a nonlinear fashion. Just an if and else blocks allow a program to branch. Repeat blocks allow a program to loop. That is, to perform a set of functions and then jump back up in the code and do it again, as illustrated in the figure on the left. When an app executes, a program counter working beneath the hood of the app keeps track of the next operation to be performed. So far, we examined apps in which the program counter starts at the top of an event handler and conditionally performs operations top to bottom. With repeat blocks, the program counter loops back up in the blocks, continuously perform the same operations. App Inventor provides a number of repeat blocks, including the for each and while do, which we will focus on in this lesson. For each is used to specify functions that should be performed on each item of the list. So if we have a list of 4 numbers, we can specify that a text should be sent to each number in the list. The while block is more general than the for each. With it, we can program blocks that continually repeat until some arbitrary condition changes. We can use while blocks to compute mathematical formulas, such as adding the first n numbers or computing the factorial of n. Moreover, we can also use while when we need to process 2 lists simultaneously. For each processes only a single list at a time. Next, we'll take a look at how we can repeat functions in an app. In Lesson 6, we learned an app that randomly calls one phone number in a list. Randomly calling a person might work out sometimes, because the person doesn't always answer the call. A different strategy would be to send a message to all of people and see who responds. One way to implement such an app is to simplify copy of blocks for texting a single number and then pass them to each person who we want to text, as shown in the figure. This brute force copy-paste method is fine and easy if we have just a few blocks to repeat. In this case, there are only 3 blocks. But if we're dealing with large amounts of data, or data that will change, we won't want to modify our app with the copy-paste method each time we add or remove a phone number from our list. Next, we will significantly modify and simplify this app with for each block. In this section, we'll learn how to simplify the iterating functions in the previous app. In this case, for each block provides a better solution. First, we define a for numbers variable with all numbers and then wrap a for each block around the single copy of the blocks that we want to perform. The figure shows the for each solution for texting a group. In other words, we can read these codes as for each item for number in the list for numbers. Set the texting object for number to the item and send out the text message. At the top of for each block, we specify the list that will be processed. The block also has a placeholder variable that comes with the for each. By default, this placeholder is named item. We can leave it that way or rename it. This variable represents the current item being processed in the list. If a list has 3 items, The inner blocks will be executed 3 times. The inner blocks are said to be subordinate to or nested within the for each block. We say that the program counter loops back up when it reaches the bottom block within the for each. At this point, we know how to make this app simple with for each. Let's take a closer look at looping blocks. In this section, we'll examine the mechanics of the for each blocks in detail, because understanding loops is fundamental to programming. When the user taps Text All button and the event handler is invoked, the first operation executed is the set texting1.message to block, which sets the message to your message. This block is executed only once. The for each block then begins. Before the nested blocks of the for each are executed, the placeholder variable item is set to the first number in the phone number list, 081 111 1111. This happens automatically. The for each leaves us off having to manually call select list item after the first item is selected into the variable item. The blocks within the for each are executed for the first time. The texting1.phoneNumber properties is set to the value of item 081 111 1111 and the message is sent. After reaching the last block within the for each, the texting.sendMessage block, the app loops back up to the top of the for each and automatically put the next item in the list, 082 222 2222, into the variable item. The 2 operations within the for each are then repeated, sending the your message text to 082 222 2222. The app then loops back up again and set item to the last item in the list, 083 333 3333. The operations are repeated a third time, sending the third text. Because the final item in the list has been processed, the for each looping stops at this point. In programming lingo, we say that control pops out of the loop, which means that the program counter moves on to deal with the blocks below the for each. In this example, there are no blocks below it, so the event handler ends. Now, we learn how for each can repeat functions in detail. Let's move on to the next section. In this section, we learn about a maintainable code. To the app user, the for each solution just described behaves exactly the same as the brute force method of copying and then pasting the texting blocks from a programmer's perspective. However, the for each solution is more maintainable and can be used even if the data, the phone list, is entered dynamically. Maintainable software is software that can be changed easily without introducing bugs. With the for each solution, we can change the list of people who receive SMS text by modifying only the list variable. We don't need to change the logic of our program, the event handler, at all. Contrast this with the brute force method, which requires us to add new blocks in the event handler when a new person is added. Anytime we modify a program logic, we risk introducing bugs. Equally important, the for each solution would work even if the phone list was dynamic, that is, one in which the end user can add numbers to the list. Unlike our sample, which had 3 particular phone numbers listed in the code, most apps work with dynamic data that comes from the end user or some other source. If we redesign this app so that the end user could enter the phone numbers, we would have to use the for each solution, because when we write the program, we don't know what number to put in the brute force solution. Next, we learn how to use the for each to display a list. When we want to display the items of the list on the phone, we can plug the list into the text property of the label, as shown in the figure on the top. When we plug a list directly to the text property of a label, the list items are displayed in the label as a single row of text, separated by spaces and contained in the parentheses, as shown in the figure on the bottom. The numbers might or might not span more than one line, depending on how many there are. The user can see the data and perhaps comprehend that it's a list of 4 numbers, but it's not very elegant. List items are more commonly displayed on separated lines, or with commas separating them. Next, we'll learn how to do it. Okay, to display a list properly, we need blocks that transform each list item into a single text value with the formatting we want. Text objects generally consist of letters, digits, and punctuation marks. However, text can also store special control characters, which don't map to the character we can see. A tab, for instance, is donated by /t. To learn more about control characters, check out the Unicode standard for text representation at http://unicode.org/standard/standard.html. In our 4-number list, we want a new line character, which is donated by /n. When /n appears in the text block, it means go to the next line before we display the next item. Thus, the text object would appear as shown in the figure on the bottom. To build such a text object, we use a for each block and process each item by adding it along with a new line character to the 4-number label.text properties, as shown in the figure on the top. At this point, we learn how to repeat functions with for each. Next, we learn more about how to repeat functions with while do. The while do block is a bit more complicated to use than for each. The advantage of the while do block lies in its generality. For each repeats over a list, but while can repeat so long as any arbitrary condition is true. As we learned in lesson 6, a condition tests something and returns a value of either true or false. While do blocks includes a conditional test, just like if blocks. If the test of while evaluates to true, the app executes the inner blocks, activity B, and then loops back up and rechecks the test. As long as the test evaluates to true, the inner blocks activity B are repeated. When the test evaluates to false, the app pops out of the loop, like we saw with the for each block, and continue with the blocks below the while do, activity C. Next, we'll learn how to use while do to compute formula. This is an example of a while do block that repeats operations. One way to figure this out is to trace each block, tracking the value of each variable as we go. The blocks within the while do loop will be repeated while the variable number is less than or equal to the variable n. For this app, n is set to number that the end user types in the text box. N text box. Suppose that the user typed a 3. The variables of the app would look like table 1 when the while do block is first reached. The while do block first tests the condition is number less than or equal to n. The first time this question is asked, the test is true, so the blocks nested within the while do block are executed. Total is set to itself 0 plus number 1 and number is incremented. After the first iteration of the blocks within the while do, the variable values are as listed in the table 2. On the second iteration, the test is number less than or equal to n is still true, because 2 is less than or equal to 3, so the inner blocks are executed again. Total is set to itself 1 plus number 2. Number is incremented. When this second iteration completes, the variables hold the values listed in the table 3. The app loops back up again and tests the condition. Once again, it is true, because 3 is less than or equal to 3. So the blocks are executed a third time. Now, total is set to itself 3 plus number 3. So it becomes 6. Number is incremented to 4, as shown in the table 4. After this third iteration, the app loops back one more time to the top of while do. When the test is number less than or equal to n runs this time, it tests if 4 is less than or equal to 3, which evaluates to false. Thus, the nested blocks of the while do are not executed again, and the event handler completes. So what did these blocks do? They perform one of the most fundamental mathematical operations, counting numbers. Whatever number the user types, the app will report the sum of the number 1 to n, where n is the number entered. In this example, n is 3, so the app came up with a total of 1 plus 2 plus 3 equal to 6. If the user has type 4, the app would have calculated 1 plus 2 plus 3 plus 4 equal to 10. This brings us to the last section. Finally, we'll take a look at the conclusion of this lesson. In conclusion, we learned how to program an app to repeat the same function by using the repeat blocks. For example, on the bank account that are processed to accrue interest, on the grades processed to compute student grade point average, and countless other everyday examples for which computers use repetition to perform a task. The key point is that programmers should consider using a repetition to make an app more maintainable. Moreover, we explore two of App Inventor's repeat blocks. The for each block, apply a set of functions to each element of the list. By using it, we can design processing code that works on an abstract list instead of concrete data. Such code is more maintainable, and if the data to be processed is dynamic is required, compared to for each, while do block is more general. We can use it to process a list, but we can also use it to synchronously process two lists or compute a formula. With while do, the inner blocks are performed continuously for as long as a certain condition is true. After the blocks within the while are executed, control loops back up and the test condition is tried again. Only when the test evaluates to false does the while do block complete. This presentation is based on the book App Inventor 2, Create Your Own Android Apps, 2nd edition by David Robert, Hal Everson, Alan Spertus, and Liz Looney, O'Reilly Media Incorporation, USA, 2014. That's the end of this lesson. Thanks for watching.